question number 2, and this is synthetic division number 2. So as a reminder, we would start by thinking of all the rational possible roots. So plus or minus 1, 2, 3, and 6 would be the factors of the constant, and plus or minus 1, 3, 5, and 15. So if you were asked to list out the possible rational roots, which you will have to do on the test, the possible ones, you'd have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and then you would change the denominator, so plus or minus 1/3, plus or minus 2/3. We already listed 1, we already listed 2. Plus or minus 1/5, plus or minus 2/5, plus or minus 3/5, plus or minus 6/5. You get the idea. All right, Mr. McFarland did say in this that we can plug this in order to identify in synthetic division 2 one of the rational roots. So I'm going to do that with you right now. I'm going to come up here, clearing it off, and I'm going to do 15x to the 4th, subtract 67x cubed, minus 19x squared, plus 29x plus 6. And I graph it. Okay. So I know that I'm supposed to have 4 different roots. I can see all 4. I can see that none of them cross through an actual integer answer. So I'm just going to select one of them and we'll work from there. So I'm going to choose to select, if I can, let's see here. I need one that is exact and not rounded. So let's try one of these. I'm going to try this one right here. I can see it's in between 0 and 1. So I'm going to go second trace. I want to know the 0 that's between 0 and 1. I'll come back and guess. And okay, this, by the way, is the same as 0. So 0.6 repeating is the same as 2/3. I know 2/3 is one of these roots. So x equals 2/3 is one of the roots. Now, after this point, I do need to show all of my algebra. So I'm going to make this upside down L, putting 2/3 out front. Okay, this is x to the 4th because it's degree 4. So x to the 4th is the coefficient with 15. Coefficient for x to the 3rd, coefficient for x squared, coefficient for x to the 1, and coefficient for x to the 0. Now, I know I'm going to get 0 because we can see that it actually is a root. But what's going to help me is what's down below. So I'm going to grab my pencil, and we're going to do this. Okay, so how do we do this? Because you have to show all of your work. Remember, you're taking taking this number times the top, in this case 2, and then divided by 3. So 2 times 15 is 30. 30 divided by 3 is 10. All right, I'm going to take 2 times 57, so 2/3 times negative 57. We end up with a negative 38. They are the same sign, so I'm adding to get negative 57. And we already did that once, so we know what the answer is. It's negative 38 again. Different signs subtract, so 29 to 39 would be a negative 9 here. And then same thing, 2 times negative 9 is negative 18. Negative 18 divided by 3 is a negative 6. Again, we knew we were going to get 0, but what matters is what's down below. Okay, now I have 15, negative 57, negative 57, negative 9 equals 0. To the left of the equal sign is no x's, 1x, 2x, and 3x. And when we first started doing this homework, we would look whenever we had x cubed and we'd say, can we factor and solve this using the method factoring by grouping? And I can already see, notice how this goes smaller to a larger number, and then if it went smaller to a larger again, I would consider maybe it could factor by grouping. This goes small to large and then large to small. It's not possible. So what do we do next? All right, so I have taken this polynomial equation and I've listed the factors of the constant and the factors of the leading coefficient. So if I was going to list these all out, I could try positive negative 1, positive negative 3, positive negative 9. Then I'd do try 1/3. This is just 3. This is 1 and 3. Doesn't work. I'd try positive negative 1/5, 3/5, and you get it, and so on, right? And so what we're going to do now when we do this, I got to move this over to the side. Hold on. So now I'm looking at this and I know that positive negative 1, positive negative 3, and positive negative 9 don't work. Because when I looked at the original function, none of the roots actually went through an integer as far as looking at the x-intercepts. But I can take what I have here. So if I break this down a little bit, and I have 15x to the 3rd minus 57x squared minus 57x minus 9. And if I graph that, and I identify one of these roots. So let's identify one of these. And let's see if we can zoom in here just a little bit. Let's take this window and change it from -5 to +5 and see if I can see them. So I have one root, two root. It looks like, oh, but I barely can see them. Okay, so it's all the way off to the side, but I can see another one. Let's identify to see what one of these would be. Let's try this one right here and see what this is. Let me move this down so everybody can visually see. So let's see if this gives me a nice answer. If these do not give me just a really clear, so we're looking for a decimal that either terminates or has a pattern. Let's try this one right here. So second trace 0. And so if I look here, it looks like it's between -0.5 and let's try even so you guys can see it, a +1. So we can see that this root is in between these dotted vertical lines. Now when I press enter, see, this is exactly what I'm looking for. I'm looking for a decimal answer that terminates, or like previously it was 0.66666, so we could easily turn that back into an equivalent fraction. So -0.2. So -0.2, if you don't know what that is as a fraction, we're going to go up to math, press enter, enter. We can see it's the same as -1/5. So off the side, I'm writing -1/5. I know that's going to be another rational root. And now I have 15, -57, -57, and -9. I know it's going to produce 0. I already can see that it is an x-intercept. Okay, so I'm going to drop down the 15. Now remember, this is like dividing by -5. So 15 divided by -5 is -3, combined to give you -16. -60 divided by -5 is +12. Let's see, that's 52. That is a -42. Ooh, this isn't looking as good. Let's see what I've done here. Maybe I've done something wrong within the math. Let's check. So 15 divided by -5, I'm good. 60 divided by -5, this is good. -57 plus 12 is, oh, that's where my math is. I subtracted wrong, is -45. -45 divided by -5 is +9, and I still get 0. So it was a small arithmetic math mistake there. What I'm doing here, this is 0, -45, -60, and 15. So this is no x's, 1x, and 2x. And I'm going to try to see if I can factor to solve this. I can look here and I can see they're all divisible by 15. Let's pull it a 15. 1x squared divided by 15 minus 4x divided by 15 minus 3. And I'm going to see, can I factor and solve this trinomial? What multiplies to equal -3 and combines to equal -4? Okay, let's see. Now I know a lot of students are going to go ahead with this particular problem, and they're going to mistaken write -3 and +1 because they multiply to give you -3, they don't combine to give you -4. Or maybe they'll say -1 and -3 because they combine to give you -4, but they don't multiply to give you a -3, it'd be a +3. What does that tell me? This isn't factorable. So forget about the 15 that we factored out. This is what we're trying to solve. So x equals -b plus or minus v squared minus 4ac all divided by 2a. Two negatives give me a positive. 16 is -4 squared is 16. A -4 times 1 times -3 is a +12, all divided by 2. So if x equals 4 plus or minus the square root of 28, all divided by 2. Now I'm going to grab my graphing calculator and I'm going to take that 28, and I know that's not going to work with 25, and I divide it by 16, it's not going to work. And divide it by 9, it's not going to work. But when you divide it by 4, we can see that 28 breaks into the square root of 4 times the square root of 28. I'm sorry, the square root of 7. So this breaks into the square root of 4, square root of 7 divided by 2. Now share that 2 with both sides. 4 divided by 2 is 2. I know the square root of 4 is simply 2, and 2 divided by 2 is 1. So I have two answers here. 2 plus or minus the square root of 7, another answer of -1/5, and another answer of +2/3.